Hello everyone, this is a class on electric circuit, and in this class we'll discuss about source transformation. In an electric circuit, a current source and parallel resistor can be transformed into a voltage source and a series resistor, and also vice versa. And this voltage source will be equal to this current into the resistor. And similarly this current will be equal to V by R. Okay, so we'll discuss this in detail with the help of a problem. Find the current I in the given circuit. This figure 1 is a circuit, given circuit. Here there are two current sources, there is a voltage source, and there are many resistors. We have to find this current I. Okay, here we use source transformation. First we can see that there is a 3 ampere source and 1 ampere source in parallel, so that we can add these two values. We get a 4 ampere current source. Now we'll draw the remaining portions, that is 20 ampere, 20 ohm here, 30 ohms here, and the remaining in a similar way. And here we can see that there is a current source and a parallel resistor. So we can convert this into a voltage source and a series resistor. In the figure 3 we can see that it is converted to a voltage source and a series resistor. Okay, and this voltage source is equal to 4 into 20, that is this current source, current 4 ampere into 20. Okay, now next figure we can see that these two resistors, series resistors, are added so that we get 50. Okay, next what we'll do is this voltage source and the resistor, series resistor, can be transformed into voltage source and a parallel current source and a parallel resistor, and this current source will be equal to I equal to V by R, that is 80 by 50, that is 8 by 5 ampere, and the parallel resistor will be the same resistor. Again we can see that there is also a voltage source and a series resistor. This can be converted to a current source and parallel resistor, and the value of this current source will be equal to I equal to V by R, that is 40 by 50, that is here it is 40 by 50 or 4 by 5, and this parallel resistor is same as this resistor, 50 ohm. Okay, the next figure, what we will do is, here there are two current sources in parallel, we can add those two, 8 by 5 plus 4 by 5, that is we get 12 by 5, and here there are two equal resistor of 50 ohm in parallel. So the equivalent resistance of these two equal resistor will be 50 by 2, that is 25 ohms. Now we got the circuit. From this we can find the current I. Here we use the current division rule. So to find current I equal to, by current division rule, if there is a current source, this value is I, there are two parallel resistors, R1, R2. Okay, and we have to find this current I. So what we will do is to find I, that is the total current I into the other resistor, that is R1, divided by R1 plus R2, which is the total resistance. This is the current division rule. Okay, now here we have to find this current I. So current I will be total current. What is the total current? Here the total current is 12 by 5, 12 by 5 into, what is the other resistance? Here we have to find the current through 100 ohm, so we have to take the resistance 25 ohms in the numerator. Okay, the total resistance, that is 25 plus 100. So we will get 12 12 into 5, that is 60 divided by 125. That is equal to 0.48 ampere. This is the current through the 100 ohm resistor.